Hello, so today we are going to do another problem from Biweekly Contest 121, this week's Biweekly. And the third problem is minimum number of operations to make x and y equal. So we get two numbers, x and y here, and in one operation you can do one of these four operations. Basically, you can either divide x by 11, if x is a multiple of 11, or you could divide x by 5 if it's a multiple of 5. Now this is important, there is a multiple of 11 or 5. Or you could decrement x by 1 or increment it by 1. And then the goal is to return the minimum number of operations you need to make x exactly equal to y. Okay, so that's the problem. For example, here with x equal to 26 and y equal to 1, we can do these operations. We can first decrement by 1, so now it's 25. So now it's a multiple of 5. So we can, in that case, divide by 5. Okay, so when you divide by x by 5, you get a 5, right? It's still multiple of 5, so we can divide again. And when you divide again, you get 1, which is equal to y, and so we return it. And so these are 3 operations, and that's, if you try a couple of other iterations, this is actually the minimum, okay? Okay, so let's try multiple cases here. So the first case that can happen is when we have, let's say, x smaller than y. So let's say maybe x is 12 and y is 15, for example. Now in this case, we can't really divide, right? Because if we divide, we will make x even smaller, and so it will never reach y. And so both the division by 5 and division by 11 doesn't make sense. Okay, so we are left with either incrementing by 1 or decrementing by 1. Now again, decrementing by 1 will even make it smaller, so it doesn't make sense. So the only operation that makes sense if x is smaller than y is to increment. And so, but how many operations do we need to get from 12 to 15? Well, how many increments do we need? We just need 15 minus 12, which is 3. We just need to increment x by 3, which is basically plus 1 3 times to get to y. So for x smaller or equal to y, it's really simple. We just need to do y minus x operations of plus 1, so of increments operations, to make them equal. So that one is easy. Now what about the case for x? If it's already equal, right, then this would be 0, and so we'll just return 0. So that's not a problem here. But if x is bigger than y, then in this case we have multiple scenarios, right? So one scenario is, let's say, the difference is not big enough. Like the difference between them is maybe smaller than 5. So let's say, for example, if x is equal to 18, for example, and y equal to 15, right? Now in this case, you can just decrement x 3 times, okay, to get to 15, right? It doesn't make sense to divide by 5 or 11 because you will get it way down than you need. So if it's smaller than 5, then it doesn't really make sense to decrement to divide, because you will get it way smaller than you need, right? But we will not do it a case by case. We can just start with the number of operations. The most you need is going to be x minus y. Because if x is like, let's say, maybe 25 and y is like 5, right? Then 25 minus 5, 20 operation, this is like the upper bound, because we can do like 1 division by 5, and that will give us 5. So that's one operation. But this is like the upper bound. And so we will need to still continue and try the division by 5 and by 11. But this is the upper bound of number of operation for cases like this. Okay? So let's get rid of this for now. Now let's see what the two other options we have. So one option we have is, as I said here, is definitely to just take the difference, subtract x until we reach y. Now the other one is to try the divisions. We have two possible divisions. We have either 5 or 11. Okay? So we will do this in a way where it works for both, but what options we have? Well, we can either, let's say for example, x equal to 23 or maybe 24 and y equal to 5. Okay, now in this case what makes most sense and is the most optimal is to increment x by 1 to get to 25 and then divide by 5, now that it's a multiple of 5, to divide by 5 to get 5, and now it's equal. So what is this? What are we doing here? Now what we are doing here is we are incrementing to the nearest multiple of d, nearest multiple of d, but up, nearest up, not nearest down. So here basically we are incrementing to nearest multiple up or bigger. Okay. Now another case where let's say x is equal to maybe 26 and y equal to 5. Now in this case we need to decrement to 25 and then divide by 5 to get to this. So here in this case we are decrementing to nearest multiple down, and these are the only two cases that we will decrement. Now I took the example of 5, but this applies equally well to 11. We will see another example, but this is the core idea here, is that for the division we need it to be a multiple of 5 or a multiple of 11. And so the only two choices we have is, let's go down to the nearest multiple of 5 or 11 and then divide, or go up to the nearest multiple up of 11 or 5 and then divide. Okay, so that's the core idea here. Now let's take another example. Let's take an example maybe where x equal to 20 and y equal to 2. Okay, so now in this case what should we do? Well, in this case we can increment this by 1 2 times, so by 2 we get 22, then divide by 11, now it's a multiple of 11, and then we will get 2. So it took us 3 operations. Okay, another potential one is you could increment by 1 to the nearest multiple of 5, so that's you need to do it 5 times, or you could decrement to the nearest multiple, which would be to 15, which in that case would be to do minus 5, so minus 1 5 times, so both are the same. Now you get 15 or you get here 25. Now if you do, then you divide by 5, now you get 1, and then you divide by 5. So if we do divide by 5, that's 3. And now you decrement by 1 or increment by 1, and this gives you 2. Now how many operations we needed? 5 plus 1 plus 1. So we needed for these 7. So either 7 or 3, and so we take 3, which is the minimum. Okay? So we will also do one where instead of incrementing up to 11 to 22, we decrement down to 11, but that's just too big, right? Because decrementing to 11, that would be 9. So you can see that one is already too big. But for our solution, we don't need to think about which one is better. We can just try them all and see which one is the best, right? So that's the core idea. Now, what are the substate for the incrementing to the nearest multiple up and decrementing to the nearest multiple up? That's what we'll do next. So let's write that down. So let me actually do this below here. So we said operations is first x minus y, and then we need to go for the divider in 5 or 11. Now we'll try both cases. One is to increment, so to decrement to nearest multiple down, to nearest multiple down for d. So in that case, let's call it divide and then decrement. We will decrement first and then divide. So let's actually call it decrement and then divide. So our state here, let's call it maybe just divide. Well, let's call it operations. Okay, for x and y. Now this is going to be how many? Well, first we will do one operation to get one operation to subtract. right, to decrement. But how many decrements we need? Well, how many decrements we need first? Let's see. So here, if we go back here to 24, how do we know we need one decrement? Well, we can just take 24 modulo 5, right? And in this case, we'll know we need to decrement by how many? By 4 to get to 20, which is a multiple of 5. Okay, same thing here for 26. How many we need to decrement by? Well, 26 modulo 5, which is 1. That's how many we need to decrement by. And so to know how many we need to decrement by, it's just the remainder, which let's call it, the remainder is going to be just, let's write it in another color. So it's going to be x modulo d. That's what we the remainder here. And so we need this many operations to get the number to a multiple of d. Right? That's what we needed here. We needed one operation to get the number to be a multiple of 5. That's what we needed here to get 20 to be a multiple of 11. Right? Because 20 modulo 11. Okay? Sorry, here 20 modulo 11, this is to get it to a multiple of 11, but to get it to a multiple of 5 is 20 modulo 5. Okay? Sorry, apologies. This was way wrong. This is actually 20 is already divisible by 5, so we can just divide to get to 4, and then we can just subtract 1 to get to 2, and so this is 2 operations. Right? So apologies for the mistake here, but still everything holds. So we need remainder, and then we need to divide, and division takes 1 operation as well. So remainder is to decrement to the nearest multiple, and then plus 1 for the division operation, and then we recurse on what? Well, we divided, and then we removed the remainder, so it's just x divided by d, and then y stays the same. Okay? So that's the first one. Now the second one is increment. The second one is to increment to nearest multiple up for d. Okay? So for that one, we can just do, let's call it increment and then divide. So for that case, what do we need? That's the tricky part here. Let's take a look at an example where we increment. I think this one is a good example, 20. So what did we do? We knew we needed plus 1 2 times. How do we find that out? Well, we know we need 11 for this specific case minus the remainder, which is the remainder for 11, 20, which is 9, which is 2. So basically it's d minus the remainder. That's what we need, the number of increments we need to get to the next level up. And so that's what we do here. So we need remainder, we need d minus the remainder. This is how many we need to increment to get to the next multiple of 11. So in this case, we need 11 minus the remainder of 20 modulo 11, which is 9. And so that will give us how many we need to increment to get to the next one, which is 22. And so in this case, this is what we need. And then one operation for the division similar to here. And then we divide. But what is the next one? Well, remember, this is the nearest multiple up. So it's x divided by d plus 1, and then y is the second parameter. Okay? And this is pretty much the 2 states. But remember, we need to take the min for each of them. And so the operations now is going to need to be, this one here is going to need to be the min of this, and well, this. And then we return it. And that's pretty much it. Yeah, so that's the main solution. We can code it up now, but this is the core idea. We get, for the case x bigger than y, for y bigger than x, it's really easy, but for x bigger, it's a little bit more complicated, but we can just do it case by case like we did here. Yeah, so that's pretty much it. Let's code it up. Just the number of operations here. If they are equal, then it's just zero operations, so we just return zero. But this is actually not needed because we can just account for it in the second one. So here we just, if it's smaller, we need to just increment x until we get to y, because both division and decrementing won't help, and so that's what we do here. If they are equal, this would be zero, so no problem there. Now, in the case where x is bigger than y, the upper bound of the number of operations is to just decrement x until we get to y. Okay. Otherwise, we'll try division. The two dividers possible we can do are 5 and 11. And so this is just the two conditions we looked at for decrementing to go down to the nearest multiple. Or we can go up to the nearest multiple. Okay. So we go down to the nearest multiple here, where basically to go down, we just need to do remainder decrementing. Okay, we decrement as many times as the remainder we have, and then we divide by d. This one operation here is for the division. And then similar thing here, we need to increment d minus rem times, and then this one here is for the division, and then we add up everything together, and then we take the min of all of those cases. And that's pretty much it for the solution. Now I cache here because here we may end up with this states with the same values, and so we can just cache to avoid recalculation. And yeah, that's pretty much it. So let's run this and submit, and this passes. Yeah, so that's pretty much it for this problem. Thanks for watching.